sometimes you get contradictory information in your data, where similar variables contain different information and information that's impossible. They cannot both be true at the same time. So I've been working a lot with oral clefts or facial clefts, orofacial clefts, maybe even. And that's when you have a little cleft in your lip or in your palate, which is the top part inside your mouth, the one that's sort of under your nose that you can press your tongue against. And one very standard variable there is do you have a cleft lip with or without a cleft palate, because that's sort of considered the same thing. Or very often these individuals with cleft lips only and a cleft lip with the cleft palate have similar characteristics. So sometimes you get yes, they do. This person had a cleft lip with or without a cleft palate. Okay, that's fine. But then you go further and then you see, does this person have a cleft palate only? And then that's also a yes, which is impossible, right? Because in one case you have a cleft lip, and in the other case you only had cleft palate, so that's it doesn't work. And there can be many reasons for stuff like this to happen, but I imagine, for example, if you have an inexperienced midwife or nurse or doctor and they need to fill out a form and then they see, this is a cleft, this child had a cleft, and this is the code for the cleft, and they just fill out more than one code because they're not really certain about which cleft they observed or which kind of cleft they observed, or they're just not thinking about it. They're saying, okay, well, let's just say all of these. So that's at least, it's one possibility. And it happens sometimes. That's if you have contradictory information within one registry, for example, the birth registry. You could also have, for example, if you have two different registries. So you could have year of death is 2008 from the cause of death registry, and then you have a variable that says alive in 2018, yes, the birth registry, right? So the birth registry believes that this individual is alive in 2018, and the cause of death registry think they died in 2008. So they can't be true at the same time. In this case, I would say, okay, the cause of death registry, they're dealing with deaths, so they're probably right. Also, it's much more difficult to sort of get a death wrong. So why would they have a registered death if the individual didn't die? It's more difficult to miss that an individual didn't die than to miss that they died. So I would say in this case, the birth registry are probably wrong, right? They're dealing with births primarily. Maybe they just didn't get the data or get the data yet that this person died in 2008. It would be very weird if the cause of death registry had them registered as dead, maybe even with a cause and a date. They probably have a death certificate somewhere, but it seems like it's less likely, right? So in that case, in the case with a cleft lip, with or without cleft palate, or the cleft palate only, we just don't know unless we have information from other registries, such as maybe the cleft and palate registry or something like that. But in the other case, where you have year of death from the cause of death registry, and then you have alive in 2018 from the birth registry, then the cause of death registry is probably more trustworthy. In general, there's no fixed solution to these problems. Just use your logic and your experience, and that's one of the things that you have to do when you're PhD students or postdocs, right? You have to just gain experience. And uh, one thing that I've experienced that I just it didn't occur to me that this was possible, but we had some data and we wanted to adjust for socioeconomic background, or it's just called social background, and it was the parents' education. And then it turned out that these kids, if they died before they were 16, we didn't get the parents' background, the parents' education. So uh, when we tried to do an analysis where we had survival as an outcome or death as the outcome, then we just didn't. The analysis were really crazy when we started adjusting for social background, right? Because by definition, if they died, then social background was missing. So that's, yeah, we had to sort that out, do everything all over, and wait for the new data to arrive. We even had to pay for the Statistics Bureau to, Statistics Norway, to correct this mistake that they had done, because it had taken too long for us to discover it. But we just didn't, it was a kind of creative mistake, so we just didn't consider it a possibility. Okay, but next time I will. Next time I get a data set like that, I'll check if there's anything like that going on. So that's the experience. Okay, sometimes variables they just have impossible values. Like if you have a birth registries that started in the 1960s or 70s, and then you have year of birth 1880, right? Or if you have a birth weight that's over 8 kilos, you just know that there's a mistake here somewhere. Often these can be detected by just plotting the variables. So that I recommend that you always do that. These are your important variables. Just plot them. Even if you have to look at 20 or 30 plots, just plot your variables. Histograms are very useful. You can try to adjust. So for example, 1880, maybe that's just 1980. Maybe you have a good reason to believe that it's 1980. Maybe this person had siblings that were born in the 70s and the 80s, for example. That's a huge task, or it may be if you have 1,000 impossible values and you have to look into all of them individually. But if you I don't know, if you have 40, then maybe you should do it. Often you can just consider these impossible values as missing. For example, the case with 8,400 grams, you don't know if they meant to write 5,400 or 3,400, right? Or 840 or 800 or 400. It's very difficult to know. Maybe you could sort of deduce that based on other variables. For example, if they're born very prematurely, maybe it's 840, but still it's a risk to do that. So you would just probably be better off if you're considering it as missing. And very often they actually mean missing. So maybe birth weight, if birth weight is missing, it's coded as 0 or -1 or 9 or something like that. And that's going to pop out in your histogram, right? If you're making a histogram and most values are 1960 or 1970, 1980, and so on, and then you have this one bar all the way down at 0, then that's probably missing data. You should read the variable descriptions again. So what do we do if we have poor quality variables? And by that, I mean variables with a lot of missing observations. Variables could have poor quality because they're not validated and stuff like that. But that's difficult to to know just based on a purely data management situation. So you wouldn't know that just by looking at the data that this variable hasn't been validated, for example. If we have variables with lots of missing observations, then we should ask, maybe it's possible to use other variables. Do we have to rely on this poor quality variable for our analysis? It's a bit like garbage in, garbage out, right? So maybe we really want to use father's education that has 15% missing, and mother's education only has 1% missing. So maybe we should just say, okay, well, mother's education it is then. It's not exactly what we were after, but it's better than introducing all this possible bias because of father's education has so much, because father's education has so much missing. And this is, mostly we know who the mother is when somebody's born, but we don't always know who the father is. The mother doesn't always want to say, and in some cases, the mother isn't maybe really that sure either. Maybe it's possible to create a composite variable. So maybe what you're after is the parent's highest education. So then you would have to have missing on both parents in order for the variable to get the missing value. Maybe there is a reason for the missingness. If you're looking, for example, at parents' education at age 25, and then you have lots of parents who are 23 and 19 and they're not 25 yet, then it's a very good reason that that the variable is missing. They're just not old enough to have been able to reach that level of education, or to even be registered with an education at age 25. We can model missingness in this case by using the techniques described earlier. We can use missing as its own category. So we can say paternal education is high, it's low, it's missing, for example. Sometimes missing just means no. If we're merging data sets, for example, that happens. If you have some rare condition, like with the clefts, for example, if you're merging the cleft registry with the cause of death registry, then the cause of death registry isn't going to have a variable that's called facial cleft. So you're just going to have all the facial clefts from the cleft registry, and then you're going to have missing. So we're going to have yes, 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 missing, 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 missing. So in this case, it just means no. And that's not a problem. You just have to know how to interpret it. In registry research, it's normally not a problem to have individuals with lots of missing observations. If we do, there may be a reason. For example, if they're a foreigner, if somebody died rock climbing or something on a vacation, then maybe we don't know the education level, and we don't know if they had diabetes and stuff like that. They may be too young, like I mentioned earlier. If you have a variable that says if we have a variable that's about education, then you have to have a certain age in order to get that education. Maybe maybe you would have, in order to have a sort of a code for what job you have, maybe you have to be a certain age. So you could have variables that are missing just because you're too young. And there can be other reasons, and you may shout them at the screen if you have any ideas. done with the shouting. It's not a problem if there are just a few such individuals. You can probably just delete them from the data because they're not going to be sort of a typical representation of your data anyway. This is unless, of course, the reason for the missingness is related to your research question. So if you're examining education in immigrants versus risk of cancer, for example, and then you have lots of missing on education in immigrants, and because they're immigrants, then that's a potential problem. Okay, that's all I had. I just want to say again, there's no fixed solution to any of this. You just have to get experience, use your brains. There are probably things that I've done in my research that you wouldn't do because you're smarter than I am, and maybe now that you've seen all the mistakes that I've made over the years, which is obviously what we've been doing in this lecture, then you know what to do, or you know how to avoid them. So maybe you're a bit better off than I was when I started working with these huge data sets. Okay, thank you.